Hello and welcome back to lesson 16.1, which is the next in our series of lessons about LMC or Little Man Computing. In this lesson, we'll look at how LMC commands include both operators and operands, and how we can add names to our programs to name the data locations, and we can use this to implement branching commands. We'll look at some worked examples and I'll set you an exercise. Every assembly language command consists of an operator and an operand. The operators are the three-letter words that we have already learned. They're commands in the language. The operands are the data values that are processed by the operators, and in the LMC language, those are numbered memory locations that store data. Here is an example of a short LMC program. Have a look at it and see if you can work out what's going on here. Each of the lines includes an operator and, in some cases, an operand. Line 1 says store the value in the accumulator to location 3. That means location 3 is the operand. Here's location 3. That's what the 03 in line 1 refers to. In the second line, the operand is 04. The command is branch to the command in line 04. The operand refers to line 4, which has the command halt, and so it stops the program. In that command, we use numbers to refer to other data locations which could store data or store commands. We can add labels to our programs to label these memory locations, and then we can use the labels instead of numbers in our commands. This makes the programs easier to read and write. So let's have a quick look at an example. Here's the same program, but two of the memory locations have been labelled. Location 3 has been given the label X, and the final line, line 4, has been given the label end. That makes the first two commands much easier to understand. Here it's clear that we're storing a value to a variable called X. And here it's clear that we're branching to the end of the program, here. So we can amend any program by naming data locations and then using those names in our programs. For example, here just two of the locations have been labelled with X and Y, and therefore we can say add X to the accumulator, add Y to the accumulator, and store the result back into location X. We can also use this naming to name a branch of our program. So here, line 3 says branch to location 6, but if we label location 6 end, it is clear that line 3 tells us to branch to the end of the program. So here's the completed program with the numbered data locations. In a previous lesson, we created this program to find the largest of two numbers. It uses numbered data locations as the operands. Identify the data locations that are used as operands and give them labels. Then change the commands so that they use the labels instead of the data location numbers. It would be a good idea to pause this presentation and have a go at this, writing it on paper. I'll continue in a moment with the completed task. So here's a very simple example. I've labelled the two data locations num1 and num2. And I've labelled the locations that we have to branch to as load number 2 and print. And I've also put in stop and start labels. So this is the completed program using labels. The way that I've set it out here is how you would write it on paper. Remember, LMC is a simulated language, so it's not identical to any particular assembly language program. So I'm going to leave you with a program to work on. Here's a program. If you're one of my students, you can find this ready-made together with an empty trace table on our Moodle. Otherwise, you can just copy it. Create a trace table for this program with the data input 3. See where it goes and see if you can work out what this program does. If you're good at LMC programming, I've got a stretch and challenge activity to make a new program that does integer division and outputs div and mod values. And in all these exercises, use data labels to label memory locations. Okay, so that's the end of this presentation, and I'll see you in the next presentation for a bit more information about labeling operands in LMC. Bye for now.